If I keep rotating my mouse 1 pixel to the left in Minecraft, you might think each of these rotations is by an arbitrary amount. However, in reality, Minecraft aim isn't continuous. It snaps to a discrete hidden grid. The length of one cell of this grid is called the rotation GCD, which represents the smallest possible amount that a player can rotate. It's calculated based on the player's sensitivity, being higher when the player's sensitivity is higher and vice versa. The important point for this video is that all rotations the player makes must be a multiple of this GCD value. We can see the existence of this GCD value for ourselves by writing a simple program to log player rotations. Upon receiving a rotation packet, our program will calculate the number of degrees that the player rotated horizontally, also known as delta yaw. Note that yaw is simply the term for horizontal rotation. After calculating the delta yaw, we will simply send this value to the chat. We can now test this program in-game. Notice that it seems I cannot rotate my mouse by a smaller amount than 0.0603 degrees, no matter how hard I try. Also notice that all of these numbers seem to be a multiple of 0.0603. If I turn my sensitivity lower, we can see that the GCD amount will decrease, and it is now 0.0328. All of the rotation amounts remain a multiple of 0.0328. We can use the existence of this GCD value to detect cheats like kill aura, which are constantly sending rotation packets to manipulate the player's aim on the server side. Basically, our check will take advantage of the fact that some cheats will rotate players by weird amounts that don't respect the rotation GCD value. In order to detect this, we will first have to learn the player's rotation GCD, which is quite difficult. This is because we, as the server, don't have access to the player's sensitivity value. After learning the player's rotation GCD, it's quite simple to check if the player's rotation amounts are a multiple of this GCD, and then if not, we will increment a buffer and flag the player once the buffer reaches a certain threshold. So how do we actually learn the player's rotation GCD? My first attempt was to calculate the delta yaws on all of the incoming rotation packets from the player, and then continuously take the GCD of these delta yaws against each other, which would maintain a rolling yaw GCD value. Then, after running this for enough iterations, it would output a final converged yaw GCD value. So for example, if we get an incoming delta yaw of 16, then our yaw GCD will be set to 16. And if we get a new incoming value of 8, then our yaw GCD will become 8. If we get another incoming 16, then our yaw GCD will stay at 8, as you can see. And the point is that the yaw GCD cannot get bigger. It will keep getting smaller and smaller until it converges to the true yaw GCD value, which in this case is 2. However, this idea fails miserably in practice due to floating point imprecision in the degrees. All of the degrees are a decimal that has a lot of decimal points, and GCD works really poorly with these floating point numbers. This makes the GCDs collapse to a very small number that is useless to us. The problem is that we can't keep taking the GCD of a delta yaw against the previous GCD for forever, because that makes the GCD collapse to a very small number like you saw previously. So the solution is to take GCDs by pair, so we will only take the GCD of each delta yaw with the delta yaw that came immediately before it. With this value, we will add it to an evicting list, which is a list that has a maximum size, and once it reaches the maximum size, it will begin evicting the oldest element of the list. Once the list reaches size 25, then we will take the mode of the list as the true yaw GCD. We can run through the same example to see how this works. If we get an incoming 16, then we will add 16 to the evicting list. And for every new incoming delta yaw, we will take the GCD of itself and the previous delta yaw value and add that to the evicting list. Eventually, we will take the mode of the evicting list to be the true yaw GCD value. In this case, 2 is not actually the mode of the evicting list, but in-game, when there are thousands of packets being sent per minute, the mode of the evicting list almost always is the true yaw GCD value. Testing this implementation in-game, we can see that the yaw and pitch GCD values are both converging to the 0.0603 value that we found earlier in the video. Note that pitch is simply vertical rotation, as opposed to yaw, which is horizontal rotation. We must maintain a separate yaw and pitch GCD value for this check, because they are very slightly different, as you can see. Now that we're able to learn the player's yaw and pitch GCD values, it's trivial to check if the player's rotations are not a multiple of the GCD values by using the modulus operator. If the player's yaw or pitch is not a multiple of the rotation GCD amount, then we will increment a buffer, and then once the buffer exceeds 20, we will flag the player for not following the rotation GCD multiple. We are now ready to playtest this check in-game. If I attack the bot normally without cheating, we can see that the buffer stays at 0 and the check is not being flagged at all. But as soon as I turn on kill aura, the buffer starts increasing rapidly and we are flagging the kill aura check. Any cheater using kill aura would have been banned almost instantly by this check. Thanks so much for watching, and please consider liking and subscribing.